So now we're finally at the point that we can actually go through, how do I come up with the equation of a line instead of it being given to me, instead of just plotting points. If I know specific factors, what does that equation look like? So we're going to talk about all the different forms. The best form for a lot of things is going to be slope-intercept form, because then we're going to be able to easily identify key features. We're going to talk about point-slope form, refresh on just what standard form looks like, and then we'll get tons of practice going through creating equations of lines. So the best, most simple form is going to be our slope-intercept form. So if you have a slope m and a y-intercept of 0b, the equation of a line in slope-intercept form is y equals mx plus b. So the reason that is because you plug in x equals 0. This would give you y is equal to 0 plus b, or y equals b. So that is going to be your y-intercept. And then the slope out front indicates that rise over line. So just as a simple example, we want to write the equation of the line with slope -3, y-intercept of 0, 4. So here, our m is equal to -3. The value of b is 4. The equation of the line is y is equal to mx plus b. The equation of the line is equal to -3x plus 4. So the reason we really like this is because it's super conducive to graphing. Instead of needing multiple points, you just need the point and you need the slope. And we're going to use the fact that the slope is equal to the rise over run. So the example we're going to go through is we want to graph the line y equals -1/3 x plus 2. So our y-intercept is going to be the point 0, 2, because that is our value of b. And then this -1/3 is our slope. So remember, m is equal to -1/3, and this is really representing the rise over the run. So the negative really just means, remember, that graph is falling. So you can think of our rise being -1 and our run being +3. So what we can do is we can just graph what that y-intercept is and then use the slope to find additional points. One's enough, but you can find 2 if needed. So we'll go up 1, 2, 3, 4. We'll go to the right, 1, 2, 3. Go to the left, 1, 2, 3. And then go down, 1, 2, 3, 4. So we start by graphing the y-intercept, which is here at 0, 2. Our rise is -1, so that means we go down 1. And our run is 3. So we go to the right 3. So this was our first point we plotted. Another point on our line is going to be 3, 1. Okay? And then we can connect the dots. You can also find more points if you need by doing the opposite. So you could also say that your run is +1, or your rise is +1 and your run is -3. To kind of do the opposite, we can go up 1 to the left 3. And that leaves us with another point here, which is -3, +3. And then we just connect the dots. And that is the graph of our line. So it makes it much easier than trying to sit there and figure out what is another point. We just use that slope to our advantage. The problem is, if we're given certain characteristics, then yes, I can write this line. But like here, I had to know exactly what the slope was and the y-intercept was. Most of the time, you're not going to be given that. Instead, you're just going to be given some point, or maybe 2 points, have to come up with the slope. But if I don't know the y-intercept, I just can't jump into writing the equation. So the point slope form is going to be really useful for actually creating the line. And then we'll want to manipulate it into slope-intercept form. So if you know the slope is equal to m and you're given that it passes through some point, which we'll call x1, y1. Then the point slope form of the line is we take y and subtract the y coordinate at the given point. It equals the slope times x minus the x coordinate. So this here is some numbers. It is our given point. So let's try an example. We're given that the line passes through the points -2, 5 and -8, 1. We want to actually write the equation in slope-intercept form. So not only do I have to find the line, I have to make sure I manipulate it back to this form of y equals mx plus b. So first and foremost, we got to find the slope. So we need to look at the ratio of our change in y's over our change in x's. So our first y value is 1, and then let's subtract 5, and then our x value is -8 and -2. So ultimately, our slope is 1 minus 5, which is -4. And then that's -8 plus 2 in the denominator. So this is -4 over -6, which we definitely don't like. Both of these are divisible by 2, and we can even say divide by -2 to get rid of both of these minus signs. So the simplest form of this fraction is 2/3. Now that I have the slope, I'm good here. We pick either point to plug into the point slope form. Again, makes no difference which one you pick. So I'm going to go ahead and use -2, 5 as my x1, y1. Okay. So the equation of our line is we take y and subtract the y coordinate, which is 5, and that's equal to our slope times x minus the x coordinate. So this is our line, but we got to do some manipulation. So this is y minus 5 is equal to 2/3 times x plus 2. I want to put it in slope-intercept form, so I need to get y by itself, and I need to be able to immediately spot what the slope and the y-intercept are. So that's going to require some work. We've got to go ahead and distribute this 2/3. So that gives us y minus 5 is equal to 2/3 x plus, so we take 2/3 and times it by 2. And we'll come up here. And that gives us y minus 5 is equal to 2/3 x. You go ahead and just multiply the numerators, so we get plus 4/3. And I want to get y by itself, so I need to go ahead and add 5 to both sides. And that gives us y is equal to 2/3 x plus 4/3 plus 5. So unfortunately, we got some nasty fractions that we've got to work with. To make them have the same denominator, we multiply by 3/3. So 5 is exactly the same thing as 15/3. And now we can actually add those. We add across for fractions, but just in that numerator portion. So 4 plus 15 gives us 19/3. And so this is our equation in that slope-intercept form. So immediately I can tell you that the slope is 2/3 and the y-intercept is going to be the point 0, 19/3. So point slope form is great for actually creating the equation of the line. Slope-intercept form is the more common one to just be able to graph and easily identify what points are. The other one, remember, is standard form. And this is just sometimes it's written this way. All of our equations have what's known as standard form, which is where all the variables are on one side. But that's just this specific form. So pay attention in your homework and on test which form it wants you to. In the last example, I'll just show you how to manipulate what we did. In the last example, the line was y equals 2/3 x plus 19/3. In standard form, this is the following. We want to get the constant by itself in this case. So what I need to do is I need to subtract the 2/3 x. And we want the x value to come first. So this is really negative 2/3 x plus y equals 19/3. So this is one version of standard form. The other thing you can do to make things cleaner is wipe your fractions. If we multiply by 3, we get the following. We multiply by 3, this would be negative 2/3 x, and then we times it by 3 plus y, and we're going to times that by 3, and that equals 19/3, also times 3. And in doing so, it ends up wiping these fractions. So that gives us negative 2x plus 3y equals 19. Just looks a little bit nicer. Or you can also change the sign on everything, like you're dividing by -1, and that is another version of standard form. So let's combine everything we know now, and we're going to write the equation of the line passing through the given points. So I've got the point 1/2 -3, and then the other point negative 2/3 -3. So I've got points. First thing I need to do is I find that slope. Once I have the slope, I use my point slope form. So we're going to start by finding our slope. And so we set up our fraction. We've got subtraction and subtraction. We look at the difference in y values. So we have -3 minus -3 over our difference in x values, which unfortunately is nasty fractions. We have negative 2/3 minus 1/2. But if you notice in our numerator, that's -3 plus 3. I really do not want to combine these fractions, and thankfully we don't need to, because in the top we have 0. In the bottom, those two definitely don't cancel each other out. So I really end up with 0 divided by a number. It's going to be 0. So at this point, maybe you can remember from our previous sections, if we have a slope of 0, that tells us there's no rise at all. So this indicates that it's a horizontal line. So it should be the equation y equals some number. But maybe you didn't recognize that. Or maybe even so you recognize at the very beginning, the y value is fixed here. So my y has to equal -3. But you're in that testing situation. You don't recognize that the y has stayed the same, or that a slope of 0 is indicating a horizontal line. This is a perfectly okay case. We can still use that point slope form. And we will come up with exactly the same equation, that y has to be fixed. The y coordinate is always equal to -3. So we can still get to that end result. So we need to take y and we need to subtract the y coordinate of either point. So honestly, it makes no difference which point we pick, but I'll use this one to create our line. And that has to equal our slope times x minus the x coordinate. But on this right-hand side, 0 times anything is 0. So that entire side just cancels out. So we really have y plus 3 equals 0, which, subtracting the 3, gives us our equation of the line that y has to equal negative 3. So we still end up at the exact same result going through our typical process. So when we're creating lines, we find the slope, use point slope form. Unfortunately, for the second example, we aren't going to be able to use that process. So if you remember when I talked about our vertical lines, those always run into a little bit more difficulty because they just have the equation x equals some constant. So here, right off the bat, just looking at these 2 points, I see my x coordinate is fixed. X has to equal 1. But maybe I don't recognize that. First thing I want to do, find my slope. So we want to look at y values over x values. So we look at our difference in y values, which gives us 4 minus 0, over our difference in x values, which is 1 minus 1. And here is where we run into a problem. We get 4 in the numerator, but in the denominator, we're trying to do 4 divided by 0. That's something that we cannot do. You cannot divide by 0. So honestly, everything I wrote is completely useless. The slope is undefined because we divided by 0. And since that's our case, this is where we're in a vertical line situation. So unfortunately, we just have to recognize that our x coordinate is fixed and the equation of our line is x is equal to 1. So this is the only time I can't go through the process of finding the slope using point slope form. I just have to recognize an undefined slope indicates a vertical line. If you have trouble with it, plot those points and maybe that will kind of trigger your memory. So if I go ahead and plot what's given to me, our first point is 1, 0. Our second point is 1, 4. Maybe then I'm able to recognize this is vertical and it's the line x equals 1. Okay. So try whatever you need to make things stick in your brain. Everyone's going to work a little bit differently with these, but there's key factors that you want to kind of be picking up on and recognizing that occur. So I just have one more example, and it's going to again tie together more concepts that we've already talked about. So we want to write the equation of a line in slope-intercept form, so in y equals mx plus b. Got to manipulate it to this. It's got to pass through the line 8, 5, and it needs to be perpendicular to 2x minus y equals 7. So to create my equation, I need a point, which I've got, but I need the slope. So we have a point on the line. That's going to be 8, 5. But we need the slope still. But using the line 2x minus y equals 7, I can go ahead and find the slope. So it's perpendicular to 2x minus y equals 7. So let's go ahead and put this in slope-intercept form. We can subtract our 2x, so those cancel. And this is the line negative y is negative 2x plus 7. And let's go ahead and divide everything by negative 1 to give us y is positive 2x minus 7. This line has slope 2. our line is perpendicular, which means it must have slope m, which is the negative reciprocal. So the reciprocal of 2 is 1/2, and I want the opposite sign. Okay. So I'm able to use that second line to figure out what the slope of the line we want is. So we now have our two key pieces of information. I have the point and I have the slope. So we can create the equation of the line. So we take y and subtract the y coordinate. It equals our slope times x minus the x coordinate. But I've got to put this thing in slope-intercept form. So let's go ahead and distribute this negative 1/2. Gives us y minus 5 is negative 1/2 x. And then we're going to take negative 1/2 and times it by negative 8. So it's y minus 5 is negative 1/2 x plus 4. Last but not least, I got to get y on its own. So we go ahead and add 5. So those cancel. And we get the line y equals negative 1/2 x plus 9. So this wraps up most of the information about our lines. We still have some more that we're going to cover in this chapter, but get lots and lots and lots of practice with these.